DisruptOps helps you find and fix cloud security issues fast. Getting bombarded with irrelevant alerts is frustrating. DisruptOps gives security and DevOps teams prioritized findings and routes relevant alerts to Slack or Microsoft Teams with automated response options that save you time. Finally, security is inside your workflow instead of in your way. Listeners can access the full platform free for 30 days by visiting securityweekly.com/DisruptOps. We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shift-left. Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself. Welcome, everyone, to this segment today. We are doing a whole series for RSA in Virtual Broadcast Alley. Here with me today is Sean Leach, the Chief Product Architect at Fastly. And of course, the segment is sponsored by Fastly. You can find out more by visiting securityweekly.com/Fastly. Sean is currently the Chief Product Architect at Fastly, where he focuses on building and scaling products around large-scale, mission-critical infrastructure. Sean, welcome to the show.
Thank you very much. Great to be here.
Awesome. And we're talking today about web app and API security, two of my favorite topics. I actually want to start with API security because I think it's really interesting when we think about the modern web app today and how heavily reliant we are both in our applications and services on APIs to talk to basically everything. What kind of challenges do you see today with your customers and with the products as well in facing the API security challenges?
Yeah, that's a great question. I think in some ways there's a lot of new application architectures out there. And with that comes, the security tools haven't always kept up to speed and kept up to date with those new architectures, right? You think of the things that people are building their applications on today. You mentioned APIs, mobile apps. Those are key for where folks are going. Mm-hmm. Those are 100% dependent on APIs. Then there's a lot of things that APIs power that are somewhat behind the scenes when you think about microservices, like the serverless architecture. You've probably heard of the term Jamstack. That's really 100% dependent on APIs. And so when you take the security solutions that folks have used in the past that are heavily focused on web interfaces and web interaction, APIs, the requests look different, the threat models are different, the attack surfaces are different. And so if customers are, with the customers that I've talked to, most of them are heavily API focused. Some of our early customers were like the leaders in APIs. We've really seen them understand and start to focus more on securing those APIs, a little bit different sometimes in their web infrastructure, but they need to still have a cohesive single solution for all of that.
Yeah, I find it really interesting how the architecture has changed over time. I think DevOps was certainly a part of that kind of progression into, I just don't have a web application that loads in a browser and that application goes to a web server that talks to an application server that talks to a database. Our web applications today are talking to all kinds of things. And like you rightfully said, sometimes it's on the client end as a mobile device, and oftentimes it's on the back end. I suppose the first step is understanding and identifying where all your APIs are. Do you guys help with that? Because that's kind of, for me, step one.
Yeah, for sure. We see a lot of people, a lot of our customers have done like tremendous number of acquisitions in a day, right? They've got like 10, 20, 30 companies they're trying to integrate. Every single one of those has their own number of APIs that they haven't itemized in the past. And so we see a lot of people are starting to try and find something they can put in front of those APIs just to provide them auditing and visibility into the APIs that they have. And then these new technologies like GraphQL, like I would say probably a good 50% of our customers are moving to GraphQL as the API technology. REST was the gold standard for the longest time, but GraphQL really allows them to push. Everybody wants to go faster. And so one way you can go faster is to give as much functionality as you can to your front end developers as they're building web applications or mobile applications, whatnot. GraphQL lets you push a lot of that technology or that kind of data out to those developers. And that's also a completely different way of looking at your API security is GraphQL, because it is different from REST. So not just itemizing them, but itemizing the types of APIs that they have and expose.
Yeah, and for me, there's a couple of basic types, right? There's the APIs that you build into your own applications. And oftentimes, as you well know, and many of our listeners, right, when you build an application, it just gets an API, or there's some program or library you can incorporate that builds out your API for you, and now your app has an API and it's great. Or you build it by hand, or you're using another service somewhere that provides an API that may be outside of your control. And those are, to me, two different security scenarios, right?
Yeah, no kidding. And I think sometimes people forget how detrimental a compromised third-party API can be, right? They spend all of their time focusing on securing their APIs if they're lucky, but then they forget about all those other APIs that, everything, we talk about the microservices and the new architectures and serverless, everything's composed of many different APIs to build up that experience that your customer sees, whether it is that mobile app or a website or web application. And if any third-party API is compromised, your entire application is compromised, right? It's the weakest link in that regards.
Right. Yeah, it's interesting. There's completely third-party APIs. I think Adrian Sanabria on our team always uses the Google Maps example, right? It's completely separate, and I call it, and I'm just trusting that what comes back from them is good or secure or has some type of integrity, right? Yep. But then I also look at the ones in your cloud provider, with our own application. For example, if you're going to transcode a video, there's an API for that. And you may have some controls over that. So that starts to get into configuration. What should you kind of think about when you're designing your application, ideally at that stage, as to how much work you put into making sure your APIs that are configurable are configured properly if you're not writing them yourself?
It's a tough one. I think that obviously, inventorying your third-party APIs, you can't protect or manage the risk of something you don't know about, right? So obviously, heavy focus on knowing exactly the APIs that you're dependent on, and then understanding the risks of each one of those. And then you're going to have to audit the security of each one of those as well. So APIs have done an amazing job of speeding agility for building web applications and mobile apps and whatnot. It's unbelievable how cool of an application you can build these days without you having to do a lot, right? Depending, like you said, on Google Maps and others. But you increase your risk when you do that. That's the only kind of thing you really have to concern yourself with is, okay, I'm taking on that risk. It's worth it probably for the speed, but you better make sure your security policies, your auditing, your security, vulnerability checking extends to those third-party APIs too.
Yeah, you're just pushing the type of risk and pushing that risk around, really. Obviously, if I control everything, I control all of the risk and vulnerabilities. But then as I start relying on others, it's still there. It's just, it could be someone else's problem. And where the responsibility line falls is really the question.
Yeah, and I don't think people should be afraid of it. It's, some of the people you depend on have some amazing security teams, probably better security teams than any enterprise would be able to hire on their own, right? Security talent, it's hard to come by. It's expensive. So not everybody can hire an amazing security team that matches the Googles, the Amazons, the Fastest, et cetera of the world. So it's okay to depend on those third parties, but you have to do your homework and your risk assessment of those third parties. It's just cost of doing business.
What are some of the typical problems, Sean, when we encounter APIs? I think if I had to pick one, it might be authentication and perhaps authorization in there, right? Is that probably the biggest one?
Yeah, I think that's a really common one, whereas people just expose their APIs and they forget to really provide any level of authorization and authentication in front of it, or they just give a token that gives full authentication and authorization for the API. So really thinking about your kind of role-based access control model that you spent so much time building in your web application, you got to do that for APIs as well. I think that like DDoSs are obviously a big focus or target for APIs just because of how critical they are, depending on what the attacker's goal is. I mean, I think most of the efforts these days, or a lot of the efforts these days, is on ransomware and like application compromise, as opposed to like back in the day when it was really common to try and take something down, right? Take an API down, take a web application down, but that threat's still there. And it can really hurt a business for your APIs being down, considering how much is dependent on them. So really, DDoS protection of the APIs is critical. And then people can try and do application compromises through APIs as well. I mean, the same coding weaknesses that you'll see on a web application for like dumping the password file, the database, a database dump using SQL injection, that can have the exact same attack surface with an API as well. So you can't just think, oh, API, it's new, so it's not vulnerable to those same like attack threats that your apps or your web apps used to be.
When I look at the attacks that are going after APIs, many of them fall into a category or this situation where an attacker is basically able to enumerate things from the API. And picking apart like those little pieces of data, like, oh, if I have that piece of data, I can query the API in a slightly different way, and I can do that at scale. I would assume that Fastly has some great defenses against that in preventing that enumeration of the APIs, right? I mean, there's a laundry list of companies that, all dating back to Instagram was one in their password reset feature. Peloton was another that had an open API. And every time I read one of these attacks, it usually comes down to like the attackers on the internet were able to query the API in such a way to be able to harvest information. That seems to me like a solvable problem with technology and rate limiting and being, knowing with signal sciences being incorporated, being able to detect those attacks and stop them.
Yeah, like what we like to talk about is you look at intent, not just like the signature of the attack, right? You think 10, 15 years ago, antiviruses, they were so focused on the signatures of what the malware looked like, but there was hundreds of thousands of new pieces of malware daily. So you couldn't just look to say like, oh, does it match this IP address? Does it match this particular hash of the binary? Right? It was just there was too much. And so some of the new technologies came out that started to look more at intent and the behavior of the application and the client itself to infer intent of were they bad, were they good, right? You're seeing the same thing on the API side and the web application side, where we look at the intent of the request as opposed to just signatures of the request. Intent might be, is this something a human could do? Could they click on a link 1,000 times in a second or something like that, right? Would a human ever enumerate the same username with like 50 different passwords within a certain amount of time, right? Those are things where you have to do that defense in depth model where you look at lots of different attributes of the request. Is it coming from a data center IP? Is it using the right, is the browser signature look right? Is what they're doing on the website or the API what a human would do? And that's where you get true kind of protection against those newer threats that are so good at mimicking real users.
And that's not so much a developer problem as it is an architecture problem, the way you've described it, right?
Yeah, it's architecture, and then it's also just like understanding the application behind the security solution, right? It's like you can't just always put one solution in front of any application and expect it to be great right away. You can start to look and then you can provide some real frontline protection, but really you have to understand the architecture, as you said, behind it. Like, is this GraphQL? Is this a REST API? Where is my login page? Where is my account page, right? You're going to have different protections on your account and login page than you might have on your front page showing like prices of the goods or whatnot, right? So it's understanding that application architecture too.
What can you do to test your APIs before they go into production to kind of minimize some of your risk? And there's been some consolidation in the market, and some begging the question: is it a feature? Is it a full product? What's your take on that, Sean?
Yeah, I think this really lands right square in the DevOps, and also now known as secure DevOps or DevSecOps. Depending on who you ask, it could be one of those two, where the only way you can truly be secure in your application development is to constantly be testing, right? Agile waterfall brought amazing value when it came to constantly pushing code out. Early on with Fastly, we saw a ton of our customers that were the most agile and the most kind of forward looking and innovative, they were pushing code 10, 20, 30, 100 times a day. They were constantly editing code, testing it, and then pushing it live. That was the essence of the DevOps model, right? Have great tests, have great automated testing, and once those tests passed, push it out to production. So you felt confident, making that many changes a day. We're seeing that now on the security side as well, especially around API security and web app security, where not only do you want to test for function of your application as you're writing new code and pushing out new features, you want to test for security as well. Did I introduce any new threats? Did I remove protection of a threat that I used to protect against with a previous version? Then I accidentally, introduced a new vulnerability. So that's where I really see secure DevOps being so great for development teams now, is they can feel more confident pushing code out more often by constantly testing for new threats, for old threats that got through. That's really where we've seen a lot of our innovative customers go to.
Yeah, that's certainly the right approach. In terms of protection, does it sit in line? Does it sit within the application? Like, where do you recommend people start looking at if you're going to implement protection? How do you integrate it into your application?
Yeah, I think it's, defense in depth again. I think one thing you have to do is you have to be somewhat in line, right? I'd say 90% of the traffic on the internet these days is over TLS. So if you're depending on some security solution that sits on some switch or router tap somewhere and is looking at that encrypted traffic, they're never going to be able to see the real threats coming through, right? Especially with a complicated, like a network-based DDoS, sure, maybe. But complicated application layer attacks, they're never going to see that. You have to be in line to be able to spot the nuances of that traffic coming through to really understand their intent. So being in line, I think, is critical at the network kind of like proxy TLS layer. But it's also beneficial to be embedded in the application as well, because sometimes threats, if they can get past the network layer, they can only be seen based on some of the data manipulation that can happen within the application itself. Like you see that with some of the RASP solutions that are out there. You want to be able to verify the security of the code itself, right? That's the defensive depth. Combine the network layer with that application layer to give you the best visibility and then protection from those threats.
Absolutely. You just reminded me of some of the tricks we pull with applications, kind of in that light, that if protections are pushed down into the browser, you can ignore JavaScript, for example, selectively ignore JavaScript, right, to get past some of those initial protections, which is really interesting.
Yeah, for sure. We see those attacks now where, like, the problem with browsers and pushing too much protection out to browsers, it's easy to lie as a browser, right? You say, like, but they're using Chrome. Like, they can't lie. Google has written Chrome to be very secure. Well, they've also open sourced it. So someone can pull down the Chromium source code, add their logic in to lie about the user agent. Obviously, that's an easy one. But even like the ordering of TLS cipher suites and everything, like the signatures of the browser itself, a lot of that can be faked, because that's one of the things you have to take into account in defensive depth is you take in signals from the client side, but you have to combine those with signals from the server side and what the intent and the behavior of the entire transaction, because a lot of times that client signal can be falsified.
Yeah. Even with proxies, I think it's Burp Suite that allows you to automatically exclude like field level security and expose hidden fields. And you just automatically, if you're lying, whatever, you run it through that proxy and it's just exposing all new things in the application. I think it's a good case for having security in your application and actually seeing those requests to weed them out.
Yeah, for sure. I mean, there used to be able to, like, early on when we were looking for bots, we would just change the DNS record. And we were like, the ones who didn't follow to the new DNS record, those were bots, right? Because they hard coded it. That was an easy one. It's not so easy anymore. People have entire farms of just basically proxying requests through end user browsers without them even knowing. So it looks like a real browser. It's coming from non-data center IPs. They can even manipulate the request pattern so it looks like a real request, i.e. it's not doing something 1,000 times a second. So it's like you have to take into account all of those aspects to truly be able to spot, like malicious intent.
Yeah, it's interesting. That's when behavior detection is super important, because detecting a bot today, like you said, is pretty hard. Attackers are going through great lengths to be able to do that. And so talk a little bit about the bot. You have bot detection kind of baked into the product today?
Yeah, I mean, we're heavily focused right now on account takeover protection. That's where we see the vast majority of, quote unquote, the badness that's out there, right? You get a dump from one place and you try that same username password combination at a bunch of different sites in an automated manner, because unfortunately, people use the same username password everywhere. So, step one, don't use the same username and password everywhere. But we do see that as a really common attack methodology. And that's where we combine a bunch of different signals to understand their intent, like data center IP, is their request pattern more often than a normal person would? Are they, attempting the same username and many passwords multiple times? Are they trying different username passwords, right? It's a combination of all of those things that really require that level of in-depth inspection. You can only see that by being in line with that type of security.
Yeah, it's an interesting example. In the LinkedIn data breach, there was, at the time, President Trump's username and password. And lo and behold, I think it was the second time they broke into Trump's Twitter account. It was the same password as the LinkedIn. They just merely reused it. And that stuff can get kind of tricky.
Yeah, and it's very common. I mean, I look at this a lot with risk, and I see these people like preparing for a nation state to compromise them. Like, okay, I got to have all this amazing security because there's going to be a nation state coming after me. And then they don't put two-factor on their Gmail account, and they use the same password everywhere. It's like, that's why I tell people when I talk to them, like, prioritize your attack surface and the likelihood of that attack and focus on that, and then move down the stack. Right, the very first thing you need to do, just protect your email with proper, email and different passwords and two-factor authentication. Don't use SMS. Use a TOTP or an app like Authy or Google Authenticator or something like that. And then walk down, because you can only protect so many things. Like, manage your risk. You're never going to be able to get rid of all of your risk, but manage it with the things that are by far the most common. Because if you look at the vast majority of attacks out there, it's those simple things that get through. It's not some super complex nation state attack that took you down.
It usually comes down to credentials. And it's interesting you give that example, in our own application, one of the ones we'd write internally, we're like, okay, so we can write our own user management, or we can just use Cognito from AWS. And Amazon's probably got a whole bunch of really talented engineers that have put that together so they can sell it as a product and service that you can then utilize. Again, back to the start, right, of this interview, it's a third-party API that you can trust, but likely that's going to be a better scenario and offer better features and address the actual attack surface that you're trying to mitigate against attacks that happen in the real world.
Absolutely. Like, yes, like, if you just use some of these like third-party services that are critical to your business, that are on companies that are focused 100% of the time on securing these things, you've gone a great step forward, because they focus, like Okta has a product out now that's pretty cool. It's around like doing your same as the Cognito, your user management for you, right? Instead of you building your own RBAC solution, you can just use theirs. That's actually a partnership that we work really closely with them on, where, because we're sitting in front of so many applications and we see so much badness come through us, we can send them signals from what we see on the internet that they can use in their authentication system, right? That's the whole beauty of the zero trust model that folks are starting to move more and more to, is the authentication identity piece is critical. So as users are using applications, we might say, hey, this client, while it initially looked legit, it's starting to do some shady things. It's dumping database, it's accessing parts of the HR system it's not supposed to. It's trying to dump the database with a SQL injection attack. So we can push those signals out to an Okta or other identity providers where they can force a more in-depth authentication. Say, well, you know what? This client may not be as legitimate as we thought. Let's make them do a two-factor authentication real quick. Let's do an analysis and make sure they're a real end user. That's the next level of zero trust, not just don't trust the network, but in real time, adjust the trust of the network and the connections over it so you can do more in-depth analysis of those particular clients.
Yeah, and Sean, you're making a great case for utilizing those services such as Fastly and Okta, because if I built some things myself, then I have to tune products to my customization and my customized software, where if I use Fastly with Okta and you folks have already worked together and you've got visibility into multiple clients to collect the data to know what to look for, and everyone benefits from that.
Yeah, you nailed it. Like if you think of like a single enterprise and they're looking at their attacks, they see just their attacks. But the beauty of working with security companies that have visibility across verticals, across geographic areas, they see all the attacks. So if you may not be targeted by a particular attack right now, so you're not going to prepare for it. Someone else might be, though. And so if you use a service that's constantly looking across the attack surfaces, you get the advantage of us seeing those different attack types and preparing to defend against those, so that when the attacker goes to use that attack against you, the customer, you're protected because somebody else already got that thrown at them, and we were able to block against it. So like using third party, now don't just trust all of them. That's another thing I get asked is like, well, how do I differentiate a good security solution versus a bad security solution? Well, don't take the marketing, literature for it. Talk to your peers, because you'll find that security solutions, people who love them, people are vocal about it. I know there's this kind of myth, right? That people are like, oh, but nobody talks about the security solutions that they use because the attackers will figure out how to route around them. That's not how it works. Like attackers are going to go after you even if they know or don't know where your security solution is. But where you can get a lot of benefit is if one of your peers who you trust says, I love this security solution, you should take a look at it. Like that's way better validation than anything else they can see. You know what I mean? Like any other kind of award or discussion out there. Trust your peers and then test it yourself. Try and break it. Try and get through their defenses. Does it fit into your architecture? Does it slow you down? Those are some of the key things I usually tell people. Absolutely.
And good vendors will welcome that testing and feedback.
Absolutely. And I get asked that all the time. Like, oh, well, like, can you just send me a report of your testing that you've done against your solution? I'm like, no, test it yourself.
Yeah.
Like, monitor us, try and break through us. Like that's the only way you'll know. Don't take what I said for, that we tested it. Right. Sure, of course, that's a PCI requirement. That's a SOC requirement. We do all these great things. But at the end of the day, the enterprise needs to test it and have that trust themselves.
Sean, that's awesome advice. I want to thank you for appearing on the show today. Encourage our audience to visit securityweekly.com/Fastly to learn more. Thanks again, Sean.
Yeah, it was great being here. Thanks so much.